Okay, saya explain sikit yang past year punya paper ni. Saya explain je saya tak bagi jawapan akhir. Okay, saya explain. So yang untuk question 1, yang ni saya tak ingat yang ni sekejap. Ini yang test semester 2 tahun 2020-2021. Okay, so question 1, this one you diberi graph, you are given I of t graph and then you need to find the value of charge, right? So charge, so you know that charge can be found using this formula, Q equal to integration of I t, right? So therefore you need to find what this equation for this graph. So usually for this one you are using y equal to mx plus c. I already teach you how to find this. You need to find the gradient over here, right? So for the gradient for the graph, and then you need to take 1 point. Okay, 1 point over here. Let's say you take x equal to this one, x equal to 2, and then y equal to 0. Just put in here. So you got a, no, this one you can get directly the value of c. Okay, because it's here is 24. Okay, so tak perlu carilah sebenarnya C tu. C tu you boleh dapat direct daripada equation. So you just need to find the M value. And then you got the I of T equal to what? For 0 to 4 second. And then from 4 to 12 second over here. So obviously is a direct current. So therefore the value will be 24. So just put all the equation in this equation, then you need to settle the integration, and then you got the value of uh, of the charge. But the question is actually to determine the total charge flow through the element between 2 second and 12 second. So that's mean from here to here only. Okay, not include this one. Okay, so next for this one, I think this one. Okay, I already discussed this one with section 2 in the tutorial class. Okay, so you are given the circuit, and then you're also given the power delivered by the source, which is PT over here. This is source, our source, equal to 2 watt, right? And then you need to find the value of V of t, and then also you need to find the value of current, and also you need to find the value of resistor. All right, so therefore from here, okay, so if you look here at this branch, okay, so this is 200 milliampere. 200 milliampere is actually the current, total current flow in the circuit, right? So that means this current will flow here and go back here, so and then go back here. That's mean our I total is 200 milliampere. So from now we know that V of t, we don't know the value of V of t, and then but we know the value of P of t. So we know that PT equal to VTIT, right? Which is P equal to VI. Okay, so PT is 2, VT we don't know, alright, and then IT is 200 milli. So from here, Vt equal to 2 divided by 200 milli. So therefore you got 10 volt. Okay, so the value of total voltage over here is 10 volt. Okay, next you need to find I1 and I2, right? So from here, uh, uh, at R2 you are given P2 equal to 0.75 watt. Okay, so therefore, okay, if you look carefully, this circuit is actually a parallel circuit, which they are connected together end to end, right? So therefore from here, parallel circuit, we know that voltage drop over here is 10 volt, and then voltage drop over here also 10 volt. Okay, so you know a, a P, and then you also know what is it, a voltage. So therefore you can find current with similar method, which is I2 can be found using this one, which is I2 is P2 divided by V2. Okay, P2 divided by V2, 0.75 divided by 10. Right? So you get the answer. Okay, you will got the answer, which is I think a 75 milliampere. Right? So please check this one. Okay. So next, if you know the value of I2, so automatically you can apply, essentially you can apply KCL at this node. Alright. So we know that current entering equal to current leaving. So KCL at this node. Okay. So that's mean I1 plus I2 equal to I total. So you already know I1, you already know I2 value. So then you can find the value of I1. Right. So then you can find the value of R and also R over here by using Ohm's law. Okay. So, okay. Question number 2. Question number 2. Show a circuit used for an amplifier system. So the circuit contains dependent current source as a control element for the circuit. Right. So determine the total current supply by the dependent current source exists in the circuit. So this is your dependent current source. Okay, we need to find the total current supply by this dependent current source. So if you look here, dependent current source is 0.01 V naught, which is V naught is actually the circuit over here, the voltage drop across 10 kilo ohm. So therefore, if you look carefully, this circuit is actually, they are not connected. So this current will flow only at 10 kilo ohm. So the current will not flow over here because we know that the current already go to the ground, right? So it's so therefore it will not go over here. So it's just complete the circuit over here. So therefore from here, okay, actually you can find the value of V naught. V naught equal to IR, which is your I is 5 milliampere, and then the R is 10 kilo ohm. So therefore V naught is equal to 10 50, right? 50 volt. Sorry. Right? So you got the value over here, and then you just put over here, which is you will get the value of current source supply by this dependent source. That means 0.01 times V naught. So therefore the current source will equal to 0.5 ampere. Right? Okay. So next, you want to find the value of current flowing to 20 kilo ohm. So this is your current, which is 0.5 ampere. So we want to know the value of current over here. Let's say I name it, this is one as I1, this one is I2. So therefore from here, we know that by applying current divider rule, so you can find the value of I2. Okay, so that's mean I2 equal to 5K 5K plus 20K times your I total, which is 0.5 ampere. So you will got the value, right? Okay, so this is mesh analysis. So I will not discuss about this because mesh analysis is not covered in your test. Okay, so that's all. Okay, so the rest I think I will share later. Thank you.